Okay, in this video, we are going to talk about how to graph a cosine wave using the characteristics and the transformations of the function. We can see here that we have a cosine of bx minus c plus d. A, b, c, and d are all real numbers. The amplitude is going to be given by the absolute value of a. This is kind of what cosine looks like, so that's what we're going to stick with here because we're talking about cosine. Here's my middle. This distance here is my amplitude. This distance here, this distance here. So the distance from the middle to the max or min. The period is going to be the distance for kind of one cycle. This one's looking like it was a little horizontally stretched, but it's going to be 2 pi over b. Normally it's 2 pi, but if it's been horizontally stretched or condensed, it's going to be different. Then we have our phase shift, which moves it left to right. You can set bx minus c equal to 0 and solve that for x to figure out what the phase shift is. Or if you identify the pieces at the beginning of the problem, you can also just remember that it is c over b. And then lastly, we have our vertical shift. Our vertical shift gives us the equation for the midline, which is y equals d. And for cosine, the midline is going to be right here. It actually starts up and then goes through the middle. Okay, we are going to use these components plus two other things to graph the cosine function. Once we have found all the other components, there's just two more things we want. And the first is the increment. The increment is going to be the period divided by 4. And that's because cosine from, here to here, one period, it's normally 2 pi, but that's what one period is. It is one full cycle. And on our 5 main points, that's what it looks like. Well, if I break my period into 4 equal pieces, it's going to give me this distance here. So doing my period divided by 4 gives me the distance between kind of my critical points that make up this cosine curve. Okay? Then this one is kind of tricky for me. I often don't think of it this way. I kind of just manipulate the points around, and that's how I figure it out. But cosine of x, normally, if it's just the parent function, it starts at 0, 1. And that's because the cosine of 0 is 1. Well, if it's been horizontally shifted in any way, that's our phase shift, that 0 is going to change. If it's been vertically shifted at all or reflected, that's going to change where the max or the min is. So it doesn't start in the middle like sine, so it's not just whatever the midline was. It's actually kind of the amplitude away from the midline, either going up if A is positive or down if A is negative. The cosine function looks like this when A is positive. Starts at 0, 1 because the cosine of 0 is 1. The cosine of pi over 2 is 0. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. So these are the 5 points that I'll sometimes refer to kind of as our critical points, our important points, when we're graphing cosine. And that's going to happen when A is positive. If A is negative, it is just a reflection. If A is negative, it is a reflection. And that means it starts down. So it actually would start at 0, negative 1, then pi over 2, 0, then pi 1, still 3 pi over 2, 0, and then lastly, it would be 2 pi negative 1. And so when we are using the characteristics, we just have to keep that in mind and use it to guide kind of our starting points. Okay? Unlike cosine that starts middle, we've already talked about this, cosine starts high, so people will sometimes refer to it and think of, because the m's can be a lot, max, mid, min, mid, max is a mouthful. So they'll refer to it as high, middle, low, middle, high. Or if it's reflected, low, middle, high, middle, low. Okay? With the piece of information on the 3 slides we just went through, we can graph any cosine curve. So that's what we're going to do. We're going to do 2 examples, one reflected, one not. Okay? It would be my recommendation to kind of pause the video and try and pick out A, B, C, and D yourself. A is going to be 4, B is going to be 1/2, C is going to be negative pi over 2, because remember, in our parent function, or kind of our general form, C is negative. It's a horizontal shift, and we know that horizontal transformations are always opposite. So that is why, because it says plus, I believe, because it says plus pi over 2, C is technically negative pi over 2. And D will be negative 1. Okay? These don't actually tell us anything about our graph, but we can use them to do so. We can use it to find our amplitude, our period, our phase shift, our midline, our increment, and our starting point. And again, why don't you go ahead and pause and see if you can figure these out on your own. My amplitude is going to be the absolute value of 4, which is 4. This one has not been reflected. My period is going to be 2 pi over b, which is 1/2. We've got to simplify that by hand, because if we tried to do it in our calculator, it would give us decimals. We keep change flip, we get that our period is 4 pi. Our phase shift is going to be c over b, which is the way I like to do it, even though that looks pretty messy right now. Negative pi over 2 over 1/2. Negative pi over 2 times 2 over 1. Looks like our phase shift is negative pi. Our midline is going to be y equals d, so that's y equals negative 1. Our increment is going to be our period divided by 4, which is pi. And it is really great when your phase shift and your period have the same denominator. It's going to make it the easiest to count up. You won't have to find a common denominator or anything like that. My starting point is going to be my phase shift, negative pi, and then I have to think about, okay, it hasn't been reflected, but the midline is negative 1, but I'm 4 up from negative 1. So I'm 4 up from negative 1, which is going to have me at 3. Again, honestly, I don't usually calculate the starting point first. I kind of plot my points, then figure out what the starting point should be. So let's do that part. Because this hasn't been reflected, it's going to be like a V, right? And I always like to do the vertical stuff first because I think it's easier. So this is my midline. Y equals negative 1. This distance, and this distance is all 4. My amplitude is 4. So if I'm at, that should be negative 1. If I'm at negative 1 and I go up 4, that's going to be 3, right? If I'm at -1 and I go down 4, that's going to be -5. Okay, because to go down from -1, 4 jumps, it's going to put me at -5. To go up, it's going to put me at 3. And that's my vertical transformations. I've taken into account my vertical stretch and my vertical shift using my amplitude and midline. Next, I want to think about my period. So from start to finish, my period is what? 4 pi. Okay. But it had a phase shift. It starts at -pi. So I'll do -pi plus 4 pi, and it should end at 3 pi. Again, it's really, really convenient when your phase shift and increment are the same, because this is super easy to count up by, right? If this is pi, then this is 0. -pi, then this is 0, then that's pi, then that's 2 pi, and this is 3 pi. And now we have enough information to plot our points. We basically have all of our points, right? This is kind of a very drawn out way to apply it. Most of the time I'm doing this in my head, but it wouldn't be a very helpful video if it was just what was going on inside my head without me trying to write it out. So this is me writing out the thought process. You can sketch it out. You can do more. You can do less. You can draw the XY tables and really do the transformations. It is up to you, but regardless of the method you use, these are kind of the 5 critical points, the 5 starting points that you should get. And I can go ahead and put those on a graph where I count up by pi. And I want both negative and positive here. And then I can plot my points. And again, I said this in the sine video, but a lot of our graphs are going to start looking alike because you can decide what the increment is. So because my amplitude's so big, I'm going to make, the dashes a little smaller on the graph. So I'll count up by, 1, -1, -2. And then on the x-axis, you just want to make sure that they're semi-evenly spread out. Obviously, easier said than done, as I just messed it up. But that way, when you connect your points and draw your curve, it seemingly makes sense. Okay, we're going to count up by pi because that is what our increment is. So pi, 2 pi, 3 pi, 4 pi, 5 pi, -pi, -2 pi, -3 pi, -4 pi, and I think we get the point. So my phase shift was -pi. It starts up. My amplitude is 4, but my midline is -1. So that's kind of the process I went through. That's kind of in the way. Let me change that. Still kind of in the way, but whatever. We get the point. Anyway, that's the thought process I went through here. So now that I've done all of this, I really just copy and paste it down to here. But if I was just going through the thought process, I would say, okay, my phase shift is -pi, so I'm going to start at -pi. I start up because it's not reflective. And since my amplitude is 4, up is 4 above the midline. Then I go over one increment and I'm at the midline. I go over another increment and I'm at the low. I go over another increment, I'm at the midline. I go over another increment, I'm at the high. And you can continue with that pattern. Increment, middle. Over an increment, low. Increment, middle. Over increment, high. Oftentimes you'll be asked to draw 2 periods, a positive one and a negative one, so we can also go this direction. Over one over one increment, middle. Over one increment, down. Over one increment, middle. Okay? Then we can connect our curve. So this was the first period. we graphed using the information from above. And then we were able to continue on the pattern in both directions to extend the curve. Okay, what is nice about these functions is they repeat. And there you go. There is a positive, zoom out for a sec, cosine function graphed. Next up, let's do one that is reflected. It's going to be the same idea, so I'm going to go a little faster, but you can always pause or slow it down as needed. Okay, let's jump right into things. I'm going to start by noting that it has been reflected. My amplitude is going to be 2 because the absolute value of negative 2 is 2. My period is going to be 2 pi over 3 because I will do b divided by 2 pi divided by b. That'll be my period. My phase shift will be pi over 3, right? You can set this equal to 0 and solve, or you can simply remember that it is c over b. That is my personal preference, how I do things. Okay. My vertical shift is up 1, which means my midline is going to be y equals 1. Okay. My increment, that's what else I need. My increment is going to be 2 pi over 3 divided by 4. 2 pi over 3 times 1 over 4. 2 pi over 12 pi over 6. So, my increment is much smaller is smaller than my phase shift, which we're not used to, but it has a bigger denominator. We want all the denominators to be the same when we're kind of visualizing this. So I'm going to call my period 4 pi over 6, and I'm going to call my phase shift 2 pi over 6. I'm going to want to count up by pi over 6. I'm just going to have to keep in mind that my period's going to be maybe look a little different than normal. Okay? The biggest thing about this one is that it starts reflected. It starts down. So when I have my kind of 4 or 5 points, it's going to be like a mountain instead of a V. Okay, there's the easy bits that I like, the easy part is the midline. That's going to be y equals 1. My amplitude, these distances, clearly not drawn perfectly to scale, should be 2. If I go 2 up from 1, that's going to be y equals 3. If I go 2 down from 1, that's going to be y equals negative 1. So that gives me kind of my range. The highest it goes is 3. The lowest it goes is negative 1. For my period, okay, from this point to this point, it should be a distance of 2 pi over 3, 4 pi over 6. But it's going to start at pi over 3 because it's been shifted pi over 3. So pi over 3 plus 2 pi over 3, this thing should end at pi, right? Pi over 3 plus 2 pi over 3 is pi. When I break it down, though, my increment is pi over 6. So to figure out what this one is, it's going to be pi over 3 plus pi over 6, which is why I mentioned it might be easiest to just think of everything for now with the denominators of 6. That's going to be 3 pi over 6, but we know that 3 over 6 is 1/2, right? So that's pi over 2. This will be 4 pi over 6 because I'm just adding pi over 6 each time. But again, that's going to reduce to 2 pi over 3. This will be 5 pi over 6. This would be 6 pi over 6. And that reduces to pi, which is what we needed. So now I have all the information I need. I have my 5 starting points. And from there, I would just repeat the pattern. So again, our graph is going to look the same. The graphs are all going to kind of look the same, which is why it's really going to depend on how you label it. Because my graph has an increment of pi over 6, that is what I'm going to count up by. A lot of times people will be like, oh, okay, yeah, it starts at pi over 3, and then they'll start counting up by pi over 6. But that doesn't work because now this is a gap of pi over 3 and this is a gap of pi over 6. When we label our axes in the math world, we are counting up. Oops, I lost my line. We are counting up by the same amount. So if I go up by pi over 6, this would be pi over 6. This would be pi over 3. This would be pi over 2 because I'm adding pi over 6 each time. This would be 2 pi over 3, 5 pi over 6 pi, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, which is 3 pi over 2. Okay, and then we kind of get the point. Right, we do want to label each side, but maybe we just start kind of spreading them out a little bit for sake of space. 1, 2, 3, 4, 5. 1, 2, 3, 4. I guess I could have those a little more spread out. 1, 2, 3, 1, 2. Okay, my midline is at y equals negative 1. No, y equals 1. Keep looking at the wrong number. My midline is at y equals 1. My first point is pi over 3 negative 1 because it's going to start down because it's been reflected. Then I'll go over 1 increment to pi over 2 and I'll be in my midline. Over 1 increment to 2 pi over 3, and I'm at my max. Over 1 increment, I'm at the middle. Over 1 increment, I'm at the min. And I can keep going with that pattern where every increment, I get a new point following that, in this case, low, middle, high, middle, low, because it's been reflected. And then sometimes you'll be asked specifically to go negative. And so we'll keep going, following the pattern where every increment, this increment, which just happens to match how I count it up, every increment is a new point in the pattern. And I can connect my curve. So my first curve was this, and you can see that this has definitely been horizontally compressed and vertically stretched. So even though I'm labeling the axes every time, this one certainly, in my mind, looks like it's been vertically stretched and compressed a little bit horizontally. But that is that. Let me zoom out.